All right, so I made a video before when I was drawing this. I recorded everything. Find out I screwed up the sound, and then I went in and tried to do an overlay on it, and I learned a lot about DaVinci Resolve, and I figured after spending 3 hours on it, it'd be actually easier to just shoot the whole video over and do it properly this time. This is the laser. And this is the glass. There's 3 different pieces of glass. This one with the bend came from Commarker, so I know it's certified. This one also came from Commarker. It was part of the housing kit, and the only thing I kept on that housing kit was the piece of glass. And then it took me a while to find one on Amazon that had the actual certification stamped on it. And so this is another one. And the ideal is, because I added this silver part, the XYZ table, to the laser, I need to make the things that hold the glass be at that height so that the glass is actually protecting me from the laser beam to the XYZ table. To do a quick, this is in no way what the laser actually looks like. What it does is, as I'm drawing things in rendering size, sometimes I get too zoomed in or too zoomed out. This allows me to come back and say, okay, I know the glass was measured right. The laser may not be perfect, but this offset between the bed and the laser is the right measurement, which matters. And this dimension, left, right, front, back. So when it sets on the ground, I know how much space the stand needs. So those are the things I own. What I'm going to build is the glass holder. This is the part that will be 3D printed. Because there are heat vents in the laser, and in case this got pushed up to the side, I wanted to have holes in it to allow that heat to come out. This, you can't really get to the laser. This is to keep the cats out. And then this will have a giant piece of plastic around the outside that's completely opaque to protect the cats. I don't need to spend a lot of money on a piece of laser glass because this angle, nobody's gonna be looking at it. So what we're gonna do today with Shapr is spend time on how to do this. Whenever you see the red dots, such as you'll see 2 red dots as I zoom in, and then I'll go to 1 dot as I rotate. Those are my fingers. This is being done on an iPad, so I can zoom in. Whenever you see the pin, you'll see the shadow of the pin. Then when I touch something, you'll see the pin. That way you know what buttons to click as I'm doing all this. So you'll see how I'm zooming it, and you'll see the button clicks, which should make a better video. Everything starts from a 2D sketch. So you come over here to sketch. I want a rectangle. And let's go ahead and make that first piece of glass. And let's say that I know the glass is 5 millimeters thick. It's not want to work. 200 millimeters wide. All right. And we know that this glass has a bend in it because we're going to do the complex one. Now we're going to make the bend, which is another rectangle. We know it's going to come off that corner, so we can just make that our starting spot. We know it's also 5 millimeters, and let's say that this length, 50. All right, that looks like the L. One of the problems is, with this object, is these crossovers. That's what the scissor tools are for. So I can just clean that up, and now I have the dimensions of the glass. But this is a glass holder. So what I want to do is I want to select the model. I want to do face offset. So this would be the face offset of the material holding the glass. I want to come out on each side about 5 millimeters so that it has enough material to hold the glass in place. We've got our 2D rough area graphic. What we want to do now, we want 70-ish millimeters to hold the piece of glass. And then from underneath here, we want it to be solid. So that's the piece that holds the glass. Let's do a copy of this. And then let's fill this area in. We could redraw it and extrude it, or we can just slide the edges over each other to fill in that gap. This can be done with the face offset or the extrude. All right, so now we have a stopper, if you want to think of it like that. And let's make another copy of that. Okay, let's take this copy, and I want it exactly, precisely underneath this one. I could try to move it and mess with it in 3D space. That is exceedingly difficult. So never do that. Always use the translate button. Find a point from where you want to go, to where you want to go. Select that. So the top corner goes to the top corner, and bam. That's actually not what I wanted to do, but you get the point. I want to take this, I want to translate this corner to that corner. Sometimes it helps to zoom around, make sure you've got the right corner. There. Now the piece of glass will fit into that 5mm hole and be stopped by this one. If you have an old printer or you're using goopy material and you need to change the offset, like 0.15 millimeters, you could also do that right here. You could also say, hey, I know it's going to squish out. I need to squish this in a little bit. I'm not going to do that right now, but I do want these two pieces to become one piece. So we'll select both of them, and then we'll come over here and do a union. That's a binary tool. I know it's not two separate objects that are lined up. They're combined. If you want to treat them as something that is not combined, but when you move one, you move the other, you can take them and make them a folder. So now I could grab the folder and move the items at the same time. So when I'm doing binary objects like union, subtract, modify, that makes two objects into one. When I put them into a folder, that just groups them so I can move them around. If you're used to vector drawing programs and grouping and combining, it's done at the folder level. All right, now I want to make this sort of have a design. And I really, so it won't fall over, I really want the base to be bigger. So let's go back to copy. Oh, come on. Select, copy. It's going to be narrow to about there maybe. I'll make another one just in case I change my mind. And then this one, we want it to be fat. So let's just select the edges, or the outside faces, not the edge. And let's extrude those by 5mm and see what happens. Is that enough? Do we want to do some more? This is parametric, so anything I do is log. So if I did a face offset and I don't like the number, I can go back and make it 10. Is that too big? Maybe 7. And you can do this through the whole history. 47 is too big. And you can go through and do this through the entire thing. I can change any of these at any time. I can pause it. So if you make a mistake, you can travel back in time with this program and modify it, which is crazy handy. Okay, I like that. Move history out of the way. I've got this bigger, fatter object at the bottom. Let's copy a few of them up, which is going to give it a path to follow. So I want it to be one solid object. I've kind of got these guidelines, and this is where the loft tool comes in. You select a face. In this instance, I want to sort the bottom, so I'm going to sort the bottom face. I come over, I choose loft, and then I just do the next face and the next face, and it will infill for me. And now it will figure out the math to make it go thinner and then straighten it up. And then I want that to come all the way to this solid piece right there. This part and that part. So let's make it one thing and do a union. Now I have one piece. We're going to grab that and we're going to rename it by holding down rename glass holder V2. It's going to be printed in black. We can go ahead and select it. Go over here to visualization. Now we need to make the vents. For the vents, we're going to do something just quick and dirty, but it's going to show you a few tools. Let's do a sketch of a polygon. You got octagon, hexagon, pentagon, and triangle. If you click triangle, you can change the number of sides. So if you want whatever a 9-sided thing is, it'll make it. Let's make it a 3D object first. All right, so this, extrude that out. Now we went from 2D to 3D. Let's come back here and look at the front. You can use the little cube up here to move around, jump to quick sections, and then spin it around if you don't like it. So you'll see me always working on the front or the top or the back on 90% of everything. All right, we select it. Let's select the object. Let's go to scale. We have a couple of different scales. This is a uniform scale. If I move it down, it's going to move it uniformly, which is good a lot of times. This is the non-uniform scale. You grab an arm and it's going to scale only on that arm. So I really want this to be squished down quite a bit, like a vent. Squish, 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 squish. All right, so we have the object we want. Let's move it into a basic orientation of, I want the vents to start right about where the laser's vents start and go up. But I don't need to go all the way up. And I don't want to draw this a whole bunch of times. This is when the pattern tool. You can do circles or linear. We're going to do linear. You can see how it's keeping the spaces even out. I actually don't want spacing. I want total distance because I want to constrain it to this area. So we're looking ahead on it. All right, can I fit 4 in there? No, let's go back to 3. Let's take it up. This is about how high I need the venting on this fat part. Let's see, about 5. 6. 6 looks pretty good, and then we can even move this around. Okay. The linear pattern automatically goes into a folder, so if you want move them around, you click on the folder, get them exactly where you want them. We'll plunge it into the model where we want the vents. I can go over a little bit more this way. We select the thing that we want to remove. Or that we want to keep. I click subtract. I click the folder so I don't have to click each item individually. We can see it gives me a preview and it shows me the items it selected. This linear pattern folder is now empty because there's nothing in it. We just did a Boolean operation. We have an item that we can print.